Welcome students. So today we are going to start with kinematics, motion in a straight line. Okay, so let us start. Motion in a straight line. Motion in a straight line. Straight line. Okay, so the first concept is here. We need to understand about 6 basic concepts here. What are those? First you can take position, then displacement, then distance, then speed, then velocity, then acceleration, then jerk. So basically there are 7 concepts. Okay, so let's start understanding what all these are. And we will focus motion in a straight line. That means body can travel only in a straight line. Let's say this is a straight line. Okay, so the body can travel either in this direction or in this direction, any of this direction. And if it's a vector quantities, we will separately, of course, we'll discuss vectors after this chapter. Why? Because mostly motion in 2 dimension, 3 dimension vectors are needed, but in 1 dimension or in a straight line we can just represent the vector quantities with having direction with sign. So any quantities having positive direction towards right side is positive and towards left side is negative. So here we can manage. So right now we will not be going into vectors, right? Even in NCERT and other textbooks you will see that vectors concept are introduced before motion in 2 dimensions, right? So that we will be taking up after this chapter. So let's now first start with the position, displacement. Only we are going to focus in a straight line. In some cases we can go in a circular motion, and there mostly distance, displacement and other things we can note it. Okay, but important formulas of vectors are there. That those things I will be of course giving the formulas here, but all details we'll discuss afterwards. Okay, so let's go next. So first we are going to understand what is position. So suppose if you want to study a body, let's say this there is a straight line, right? And body position of the body is, let us say here, this is a body, right? This is a body, and you want to study the position of this body. So first of all, there has to be a fixed point called origin. This origin is a fixed point, right? And the observer who wants to study this object, he is supposed to be at the origin. So with respect to the origin or with respect to the observer, we want to study the position of this body. So position means from here, this side, it is this side, it is positive direction. So position itself is a vector quantity. Don't think that position is not a vector quantity. Position itself is a vector quantity, and let's say its position in general, x is equal to x. It can be x is equal to 1, x is equal to 2, anything it can be, right? It can be negative also. Negative means it is towards the left side of the origin, right? So position is nothing but it is the location of the body with respect to the origin or with respect to the observer. Okay, that's what is position. Position means location or coordinates, you can say coordinate of the object with respect to the origin or observer. Now here it is important to know the concept of frame of reference also, because observer is at this point, right? This is observer. So what frame of reference it is? What is frame of reference? Because observer may himself be moving, then he will not be remaining fixed, right? And observer may be under acceleration, observer may be at rest. So there can be different, kind of motion depending on how we see the object from what reference frame. So we need to also understand here reference frame or frame of reference. So it is nothing but it's the coordinate system based on which we study the kinematics, or even dynamics we can say, but that we'll see later. Based on which we study the kinematics of the body. Kinematics means the motion, right? The study of motion. We want to study the motion of the body, like the distance, displacement, position, velocity, acceleration, all these things from a particular coordinate system. That coordinate system is the frame of reference. Okay. So here we keep that origin person, at origin is fixed, and then its rest, then it is observing the body, right? And this is the instantaneous position, x is equal to x. Okay. Now this x can be changing. So if let's say x is equal to constant, and x is equal to not constant, changing. So based on this we can say if x is equal to constant, that means body is not moving, that means the position is fixed, right? With the body is itself position is constant, that means it is at rest. Okay, and if x is changing, that is what is motion. So if the position changes, then it is at motion, and if it is not changing, it is at rest. Again, as I told, it depends on reference frame. So if the observer, let us say if you are going in a train and you see outside things moving, right? Because you yourself are moving, although outside is stationary. So everything is relative with the observer. So most motion and rest, they are not absolute term. Rest, motion, or anything kinematics which you are studying, it is with respect to the frame of reference. Okay, right? Then let's go to the next. Now once we have understood position, let's understand displacement. Displacement is also a vector quantity, right? Just like position, displacement is a vector quantity. Let's say that there is a body and the body is displacing from this position to this position. Okay, from this position to this position, it's displacing. So it may be displacing gradually, right? First time here, then here, then here, like that it is displacing. So initial position, let's say this is the initial position of the body, right? And this is the final position of the body. So over an interval of time it has moved. So let's say here this position is x is equal to x1 and time t is equal to t1. Similarly, this position is x is equal to x2, time t is equal to t2. Right? So let's say this is the origin, which is x is equal to 0, right? So body has moved in this direction, right? It has moved from this to this. So this is the displacement. Displacement is a vector quantity which starts from the initial point to the final point, and it can be represented by this arrow because it's a vector quantity, right? And how do we calculate displacement? So displacement is delta x. It is final position minus initial position. This is the formula to calculate displacement. Okay, so displacement can be calculated as final position minus initial position. Okay, then let's go to the and displacement can be positive, it can be negative. If let's say delta x is positive, then the body is moving towards right side. If delta x is negative, body is moving towards left side. Okay, so positive negative direction vector is included here itself. Okay, then let's go to the, and it's a vector quantity. Then next is, let us say about distance. So suppose the body, we are taking a straight line, but it can be any other case also. Suppose if body is going from here to here. So first let's say body is here, then body comes here, and then let's say body comes here. Okay, I'm taking, let us say, 3 positions. This is 1, and then this is 2nd position, and then this is 3rd position. Okay, 3 positions I have taken. So this is x is equal to x1, this is x is equal to x2, this is x is equal to x3. This was t equal to t1, t equal to t2, and t equal to t3. Okay, so how the body is moving, if you see, body is moving from here to here first, and then body is moving backward like this. Okay, so there are two motion. One is forward motion, one is backward motion, right? This position is 1, this is 2, and this is 3, right? These are the 3 positions. So how do we calculate distance? Remember distance, what is the distance? Distance is the length of path traveled. Distance means length of path traveled. Okay, so if you see, the body is moving from where to where? 1 to 2, 2 to 3. So here we are going to write distance. Distance generally is written as L. Okay, L means distance. So this length of the path is from 1 to 2. You can say L 1 to 2, then L 2 to 3. Like this you can write. Okay, and remember, this is a straight line path. It can be positive, negative if you take displacement. So what we can do is, this forward and then backward we can just take as the magnitude of displacement. Displacement you can write delta x 1 to 2. Similarly you can write here delta x 2 to 3. Right? Now displacement, 1 to 2, how to write? You can write as x2 minus x1. Similarly, keeping in magnitude 2 to 3, you can write as 3 minus 2, right? Although any one of can come negative, but you are taking magnitude, so it will get added, right? And because it's a straight line, so displacement in a straight line we can write it like that. Okay, but if it's a curved path or other thing, then you have to think in a different manner. Distance and displacement. Okay, so now let's go next. Next is, what is speed? Speed is nothing but it is the rate of change of distance, right? And speed formula is given as distance by time. Now here there are two concepts. One is the average speed. Average speed means it is total distance by total time. Now total distance traveled is, let's say, delta L in a particular interval time, delta t. So that's what is average speed. Okay, what about instantaneous speed? Instantaneous speed. Instantaneous speed means at a particular moment, what is the speed? So this is differentiation dl by dt. Now we have studied differentiation, so we can definitely apply the concept of differentiation, right? So this is instantaneous speed, that's average speed. Then let's go next. Same way, what is velocity? What is the concept of velocity? So velocity is rate of change of position. So velocity definition, velocity is equal to displacement by time. And now if you see, if I want to write again average velocity. Average velocity will be total displacement by total time. And instantaneous velocity will be what? And here total displacement you can write delta x by delta t, and this will be dx by dt. Okay, instantaneous is nothing but it is the differentiation, right? We have to do differentiation of position with respect to time, delta x by delta t. Okay, then let's come to acceleration. What is acceleration? Acceleration is a rate of change of velocity. How velocity is changing. So acceleration can be defined as change in velocity divided by time interval. So again here we can define average acceleration. Average acceleration is taken over the interval of times delta v by delta t, and instantaneous acceleration will be dv by dt. Okay, right? So these are the very basic concept that we should know. Now let us note some important points, right, regarding these things. Let's make a note of some important points. First thing is that, and of course jerk is there. Jerk also you cover, but generally jerk is not being used. Okay, but jerk is also a physical quantity. Okay, it's also a vector quantity. It is rate of change of acceleration. Okay, so again we will define that jerk as change in acceleration by time interval. So here again we can define jerk as average jerk. Average jerk will be delta a by delta t, change in acceleration by time, and instantaneous jerk will define as dA by dt. Right? Now let's note the important points. Let's make note. First, the distance is always greater than equal to magnitude of displacement. Okay, so sometime they may ask what is the magnitude of the ratio of distance versus displacement. If they ask this magnitude, it will be always greater than equal to 1. Okay, next you should note that what will happen in some cases where there is a circular kind of motion. For example, suppose if a body is going in a circle like this. Okay, now let's say body goes from point A to point B. Okay, and the radius of this circle is r, and it has moved an angle theta. So what is the distance and displacement? Distance is what? Distance is the length of the arc. You should remember this path length, right? This is distance. And what will be displacement? Displacement will be this line, which is the chord AB, right? So here we should note the formula for distance. So distance is arc length. Arc length is r into theta. Okay. Remember here theta is in radian. Radian we have to use. Okay, and what will be displacement? displacement formula will be the AB chord length. AB chord length will be given as 2r sine theta by 2. By trigonometry we can do the solution and calculate. Okay, so we should note this distance displacement formula in a circular motion, right? Then let's move next. Now it is important to know about graphs. Already we have discussed about graphs. In graphs we have discussed three things: slope, shape and area. Now here we will see the applications, right, briefly. So let's take graphs. So first, if you take position time graph, xt graph, so what does the slope of this graph indicate? So any point if you take, like this theta, so slope of this graph is dx by dt, which is tan theta at a, it is the slope of tangent, right? So this represents what? Velocity, instantaneous velocity. We know velocity is dx by dt, right? Okay, and here average velocity if I have to calculate, then we have to take second. For example, if this is the graph and you need to take 2 points, right, then you can join this point, like you can see delta x by delta t, because along this delta t, along this delta x. So if you join these two lines, right, if you join these two lines, then this tan theta is the slope of second. Here the slope will be delta x by delta t, which will be nothing but here also tan theta. This will be average velocity delta x by delta t. Okay, so from the graph we can understand there will be 2 points, 2 different points they will give on the graph, and slope of that line joining these 2 points will be average velocity. But at a given point, if you draw the slope, instantaneous velocity you will get. Okay, that is the slope of xt graph. Then let's go to the next, and there can be different kind of motion can be represented from the graph, that we'll discuss after. Now second, if you take vt graph, let's take vt graph. So if you are taking vt graph, here this is velocity, this is time, right? So vt graph, let us say again it is like some kind of a curve. So again the same concept, if you take any particular point, right, and you can draw the tangent at that point, then here what will be the slope? dv by dt, that will give us acceleration. This is the slope of this graph. Similarly, if the graph, if you take slope of second, that means 2 different points if you take. For these 2 different points again, you can see this is delta t and this is delta v. So when you join these 2 points, this theta here, it will be, instead of dv, it will be delta v by delta t. That is the average acceleration, average. Okay, this is the slope of the second, right? But here there is more important thing to note is about the area. So if vt graph is there, right, and let's say the graph is like this, then between any 2 points, let's say t1 and t2, between any 2 time instant, what does this area under the graph indicates? This area. Okay, so if you take area under, what does integration means? This is v dt. Okay, this is what is the area. And what is this v dt and how do we come here? So v is equal to dx by dt. So if you do v dt, it will become dx, right? And then you integrate this v dt. When you integrate this dx integration is delta x. Now that is what is the area under graph. Delta x is area, right? So we can understand that delta x is displacement. So the area under this graph will give displacement. Okay, this we can note the area under VT graph. Area under VT graph will give delta x displacement. Okay. Then let's go next. Third, if you take AT graph, acceleration time graph. Again, in acceleration time graph, you can define instantaneous slope, right? So here dA by dt will give jerk, right? Similarly, if you take average slope, that means between 2 points you join that, right? So you will get this as delta A, this is delta t, right? So here delta A by delta t, that will give average jerk, average, correct? When you join this, that tan theta will give us average jerk. Okay, but here also again we need to understand area under the graph. So if this graph is like this and in between 2 points, right, we can calculate the area under this graph, area under acceleration time graph. So what does the area under this graph will give? Again in the same manner, integration of A dt. Integration of A dt will give integration of what? dV, which will be delta V. Okay. So area under this graph gives change of velocity. Change of velocity under acceleration time graph, right? Area. This we should note. Okay. Then there can be another type of graph also. Let us take fourth. Suppose this is AX graph, acceleration position graph. What does this will give? Okay, so acceleration, which is written as dV by dt, right? Acceleration can also be written as dV by dx into dx by dt. If we write dx by dt as v, then dV by dx into v, acceleration. So acceleration into dx will become v dv, right? And when you integrate, this is the area under this graph, area. So v dv is nothing but v square by 2, and let's say you are going from initial velocity v1 to final velocity v2. So it will become v2 square minus v1 square by 2. Okay, so that's the area under this graph. The area under this graph will be calculated by this. This is the area under this AX graph. Okay, so we can calculate these concepts from the graph, right? Okay, so then we will move next, right, in the next class.